Let's talk about something truly amazing. A story about how artificial intelligence is being used to save a language and a culture for generations to come. We're talking about the Yoruba language and a really clever project to make sure it has a voice in our digital world.
I want you to just think about this for a second. What if the technology you use every single day, your phone's voice assistant, translation apps, even your GPS, what if it just couldn't understand you? That's the actual reality for billions of people. It's this huge digital divide, and it means that so many voices are just not being heard.
So, here's how we're going to break this down. First, we'll look at the problem, this digital language divide, and why it's so tough to build the data that languages like Yoruba need. Then we'll get into the brilliant AI solution that a team of researchers came up with, including a really cool algorithm they invented from scratch. And finally, we'll see the results and talk about what this means for the future of so many other languages.
Okay, so let's start with the heart of the issue, the digital language divide.
You know, we're not talking about some obscure language here. There are an estimated 47 million people who speak Yoruba. It's mainly spoken in Nigeria, Benin, and Togo. But there are communities all over the world, from Brazil to Cuba. It is a major global language.
And this is where it gets strange. It's a paradox, really. In the world of tech and AI, Yoruba is called a low-resource language. All that means is there's just not enough digital data, text, audio recordings, to train AI models properly. And without those models, you can forget about building things like speech-to-text, translation apps, or voice assistants. The language is literally at risk of being left behind, of being digitally silenced.
So, this brings us to the big roadblock, the data building dilemma. Why is it so ridiculously hard to get all this data in the first place? Well, here's the fundamental clash. The old-school way of doing this involved hiring tons of fluent speakers to record thousands and thousands of hours of audio. It was and is incredibly slow, super expensive, and honestly, the quality can be all over the place. But modern AI, it's hungry. It needs massive, high-quality datasets to learn from. The old way just can't scale.
So, this is where the researchers got really smart. They knew they couldn't climb that mountain of manual work. So you know what they did? They built a bridge, using AI itself.
And this is their master plan. Now, I know it looks a little complicated, but the idea behind it is just brilliant. Instead of starting from zero, they designed a hybrid system. It takes existing, kind of messy data and then uses AI to clean it, fix it, and then multiply it into something huge and actually useful.
It really just boils down to 4 clever steps. First, they got their hands on a small, existing dataset. Second, they used AI to clean up all the corrupted text and get good translations. Third, the original data didn't have any English audio, so they just used another AI to create it from scratch. And fourth, this is the really cool part, they invented their own new algorithm to just massively multiply everything they had.
And get this, their starting point was tiny. They began with just a little over 1,500 audio samples of Yoruba, but the text that came with it was a garbled mess, and there was no English audio to match it at all. It was basically an incomplete, messy foundation, but it was a start. Okay, so this brings us to the most mind-blowing part of this whole project, their custom algorithm, which they called AcoustAug. And I love this description. It's basically a form of digital alchemy.
The secret sauce here is something called audio augmentation. The idea is simple. You take one audio file, and then you create a bunch of new, unique versions of it by just making these tiny little changes, like tweaking the pitch, the speed, or the volume. And this visual shows you exactly what's happening. On the left, you see the sound wave of an original Yoruba recording. Then AcoustAug works its magic. It creates multiple new samples by slightly changing things. Now, to our ears, they might sound almost identical, but to an AI model, each one is a brand new piece of data it can learn from. It's genius.
So how effective was this little trick? Unbelievably effective. They took every single one of their 1,504 original files and used AcoustAug to create 7 new variations of each one. That multiplied their dataset 8 times, turning that small collection into over 12,000 unique samples, just like that. So, the million-dollar question, did it actually work? I mean, it's great to have a big dataset, but is it any good? To prove it, the researchers used their new data to train a brand new text-to-speech model for Yoruba. They called it Yoru TTS 0.5. Let's actually look at the results. This graph is really cool. The blue line is the pitch of a real human speaker. The yellow line is the AI-generated speech.
After about 540 rounds of training, you can see the AI, the yellow line, is kind of trying to follow the human pitch, but it's a little wobbly. It's learning, but it's not quite there yet.
But now, look at this. After 1,000 training rounds, wow, that yellow line is hugging the blue line so much more closely. The AI's voice is now matching the pitch and the rhythm of the real speaker much more accurately. This is exactly what you want to see. It's clear proof that the model learned from all that data they created.
So the final pitch error came in at about 63.5 Hertz. Now that number might not mean much, but here's the important part. The researchers said that when they had real humans listen to the AI's voice, they rated it as having a high degree of perceptual naturalness. In plain English, it sounded good. It sounded natural. The proof of concept was a huge success.
And this is where the story gets really exciting. Because this isn't just about one language, this is about creating a blueprint for the future. Just look at the final numbers. The final dataset is huge. It has over 24,000 audio samples, totaling more than 41 hours of audio for both English and Yoruba. And to put that into perspective, a lot of similar datasets for low-resource languages have less than 20 hours. They basically created a world-class resource out of almost nothing.
And I think the researchers themselves put it perfectly. They said their work contributes to the bigger goals of language inclusivity and equitable AI. This was about more than just data. It was about making technology fair for everyone.
What they've done here is create a roadmap, a cost-effective, AI-driven way to build these crucial digital resources for any language that's being left behind. So the question this leaves us with is a really hopeful one. If they can do this for Yoruba, which language could be next?